Dear student, myself Rajendra Aaseri. I am assistant professor in computer science department at Government Bangat PG College, Didwana. In the previous lecture, we started a lecture series on database and management system. In that lecture series, we discussed about various physical media devices, and then we discussed about the storage hierarchy in that storage devices. Up to this point, we discussed about overview of physical storage media. In this, we discussed about various devices like cache, main memory, magnetic disk, magnetic tape, okay, and the processing and performance speed of those devices. Then magnetic disk in very much detail we discussed various levels of RAD we have discussed, and in the just previous lecture we started a new topic on file organization. In file organization, up to this point we discussed that what basically a file is, in file how to insert a record, and in order to delete a particular record what type of alternative or what type of strategy we can follow. Now, after that, in record, there are two type of record. First category is fixed length record, which we discussed in the previous lecture. And when a fixed length record is deleted, what will happen? It will be added to a free list with help of a pointers, right? So all these concept we already discussed. Now, continuing in today's lecture, the concept is variable length record. So what is variable length record? As the name implies, variable length means the record which can vary in length. Okay. So variable length records arise in database system in several ways, like storage of multiple record types in a file. Second, we can record types that allow variable length for one or more field, record types that allow repeating fields, which are used in some older data models, right? So if you see here, the structure is given of for the variable length record. So this is the size, location, and there are various fields are there. So if you see, the first field is related to block header, okay, in between free space is there, and at the end some records are entered. So if you see, various entries are entered in a block header, in between some free space might occur, and if you see, these are the pointers, okay. Pointer will, every header will point a particular record with the help of the pointer, okay. So in this manner, variable length record can be maintained in a file, right? Now next is variable length record are based on a slotted page structure. What is that? In slotted page, a header contain the number of record entry. The first entry in the header is how many records are entered. The number of records entry will be there. Second is end of free space in the block. If you see, the first is the field is the entries, then it will give the end of free space, and at the end some records will be entered, right? So if you see, number of record entry, end of free space in the block, third is location and size of each record, right? Now, records can be moved around within a page to keep them contiguous with no empty space between them. Entry in the header must be updated, right? So, in the header, we can update the entry as and when required. Third point, pointers should not point directly to the record. Instead, they should point to the entry for the record in the header. Okay, so pointer task is just to point a particular record, and they should not point directly to the record. Instead, they should point to the entry of the record in that particular header, right? Now, in order to organize records in a file, there are various structures, various concepts available. So they are listed in this slide, and we will go through all the concepts one by one, right? So the first concept is heap. What is heap? A heap is basically a record that can be placed anywhere in the file where there is space, right? Second is sequential. It stores the records in sequential order based on the value of the search key of each record. Okay, so in sequential record, we can store the record in sequential manner, and they are based on the value of search key of each record, right? Third is hashing. A hash function computed on some attribute of each record, right? The result specifies in which block of the file the record should be placed. Okay, so hashing includes some modulus type of function. Based on that, we will pick that in which particular block the record will be placed, right? Now, record of each relation may be stored in a separate file. In a multi-table clustering file organization, records of several different relations can be stored in the same file, right? Very important point. Means there is a special case in file organization that is called as multi-table clustering file organization. Multi-table clustering file organization. In that, what will happen? The records of several different relations can be stored in the same file. Okay, multiple relation or multiple table records are combined and put in the same file, right? That's why it is called as multi-table clustering file organization. Now the motivation behind it is that it stores related records on the same block to minimize the input and output operation, right? Now next is sequential file organization. As the name implies, in this the records are put in sequential manner. Now this type of file organization, that is sequential file organization, is suitable for applications that require sequential processing of the entire file. The records in the file are ordered by a search key, right? Suppose in this example, if you see, there are three columns. First column will say the index. So the index are like A217, the for first record, and the second column entry is Brighton, and third is 750. Now this is pointing with help of pointer to the second record. Second record is pointing to the third record. If you see this scenario, there is no skip among the pointer. It means they are sequentially pointing. First record is pointing to second, second pointing to third, and so on, right? So this file organization of records is called as sequential file organization, right? Now in sequential file organization, if we want to perform the operation, right, like insertion, deletion, updation, then how to do that? So they whenever we are doing some updation like insertion, deletion, or any modification, then it is all the game of pointer. Means we, with the help of pointer, we can do delete the record, we can insert a new record, and many more things we can do. So first we are doing the in case of deletion, what we need to do, we need to use pointer chains. What is that? You will come to know. Next is insertion. So in this slide we are understanding about the insertion process. So first diagram, with the help of diagram I will explain later. First understand the concept. So in insertion, what we are doing, we locate the position where the record is to be inserted. First we need to locate the actual position where we want to insert the record. Okay, means entry record number we need to position. If there is a free space, then insert there. If there is a free space in between, then we can insert the particular record at the required position. Second possibility, if no free space is available, then we can insert the record in an overflow block. Overflow means additional empty block. In that block we can put that particular record, insert the record which we want to add, and then just point the pointer to that particular new record, right? In either case, pointer chain must be updated, right? Because a new record is entered in between, so we need to change the pointer chain, either we are inserting in free space or we are inserting in the overflow flag, right? Now we need to recognize the file from time to time to restore in the sequential order. So if you see in this diagram, there are various records, they are sequentially stored. Now suppose 1, 2, 3, at fourth position, we want to insert a new entry. Currently the entry at fourth position is A215 minus and 700. At this place we want to enter a new record. So the new record tells A888 north town and 800. So third record will fourth record was pointing to fifth record. Now third record will point to the third record is pointing to what? The new record, and new record is pointing to the fourth record. So fourth record now will become the fifth record and new record will be now fourth record. So in this manner we can insert a new record in sequential file organization, right? Next is multi-table clustering file organization. In this there are more than one table existence. Why? Because it is multi-table, and from more than one table we are just combining the record and we are making a single table, right? So it store several relation in one file using multi-table clustering file organization. So if you see, the first table is tells about customer name and account number, and in this there are 4 records are available, right? Next table says customer name, customer street and customer city, and there are 2 records available in this particular table. Now with the help of multi-table clustering file organization, we can combine these 2 table and we can make these columns or these records in a single file, right? Next is in multi-table clustering file organization. So in the particular example, multi-table clustering organization of customer and depositor will says about see 2 records. If you see, the first record and the fifth record are related to the second table. Second table means Hayes, Maine and Brooklyn. This is the first entry. If you see, this is the first entry, okay, and the second entry is here, Turner, Putnam and Stamford, right? So second table is clear. Now remaining 4 entry are customer name and account number. So if you see customer name and account number, customer name is Hayes A102, Hayes 2220, Hayes A503 and Turner A305. These are the entries corresponding to the first table, right? Now it is good for queries involving depositor. Why? Because in case of depositor, some attribute we need to take from customer and some we need to take from account, right? So for account for depositor queries, it is very helpful, this type of multi-table clustering organization. Now it is bad for queries involving only customer. If only customer queries we need to do, then there will be some redundancy, some information are in the table which is not required, right, in the query. Now it result in variable size record. Why? Because if you see, first record is having 3 attributes, second, third and fourth record is having 2 attribute, and fifth again 3 attribute, okay, and the last one again having 2 attribute, right? So it is a file organization with variable size record. Now we can add pointer chains to link records of a particular relation, okay. Next is data dictionary storage. Now data dictionary, which is also called as system catalog, it stores the metadata, that is data about data, like information about relation, like name of relation, name and type of attribute of each relation, name and definition of views, integrity constraint, right? All these information comes under metadata category. Next is user and accounting information like password. Third, statistical and descriptive data. In this we can write down number of tuple in each relation, Okay, that also can be put under data dictionary. Next is physical file organization information, means how relation is stored in sequential manner, hashed manner, and some other manner. Then physical location of the relation is also put under physical file organization information. And last is information about indexes. Next is data dictionary storage. If you want to store data in the data dictionary, then some techniques are there. Catalog structure. Catalog structure will just put the data in relational representation on the disk. It will specialize the data structure designed for efficient access in memory, and some possible catalog representation is given here. If you see, the relation metadata is relation name. It will contain relation name, number of attribute, storage organization, and location. Second, attribute metadata, it will contain attribute name, relation name, domain type, position, and length. Third is user metadata, which contain username, encrypted password, and group. Fourth is indexed metadata, which contain index name, relation name, index type, and index attribute. And the last one is view metadata, which contain view name and view definition. All of you know what is view, what is relation, what is attribute, record. All these things we already covered in the database and management system lecture series, and various queries we made practiced on this type of concept. So that's all from this lecture. In the next lecture, some new concept we are learning about the physical data storage concept. Thank you.